Hi everybody, and welcome back to the bench. So we have our next project here that we're going to work on, and I think I showed it to you on the last video here, the frequently asked question video, and it is a Carver TFM-35x power amplifier. And I like this one because it has these neat little round meters on it. I always thought these were cool looking. Now, I do not know what this video is going to entail because I don't know anything about this amp, if it works, if it doesn't work. It may work and they just want it checked out, in which case this is going to be a pretty short video. It's just going to be a show and tell about this amp, or it may end up being a repair video. We'll see. The one thing I will say is that it is a little bit different from all the other Carver gear we've done, which is one of the reasons I chose to go ahead and do another Carver amp, and that is that it does not have the magnetic field power supply in it. This is a more updated Carver product, and it still has the rail switching, which is the Class G amplifier output stage, but it has a more conventional type power supply. So, without any further ado, let's check this thing out and see what kind of video we're going to make out of it, huh? As is customary on this channel, whenever I get something in that I don't know anything about it or not sure, I'm going to take it apart before I plug anything in and just make sure there's no damage or anything like that. So, I'm in the midst of taking the screws out. So get those out here. Get this turned around so we can all see what's inside. Like I said, this amp might be just in good condition. Oh, got some back screws to take out. Hold on. And you can tell this does not have the magnetic field power supply because this amp for its size is very heavy compared to, if this would have been a magnetic field amplifier, it would have probably weighed about half as much as this one. The other thing I noticed, it did come, somebody put in a bag the little rails on the front, the little brackets, and it looks like they've been kind of, you can see how the cover's been bent from that, so we'll have to straighten that out for sure. But here we are. Let me set this cover down. And there you are. Let's see if we can see any flames or anything. I don't know what this goop is on top here. Ugh. Sticky stuff. So, I don't know what that's all about, but something is melted up there. But as far as the circuit board's concerned, I don't see anything obvious burned up or anything like that. So probably if the amp does have problems, it's not something really serious. We'll check the fuses in the back because the fuse is back here, and see if it's okay. And if everything looks good there, then maybe we can just try turning this on and try it out. The other thing I noticed is a couple of relays. I did not open the schematics for this. I do have a service manual for this, but I didn't open it up and look at it very much. But it even looks, 2 relays, maybe I'm wrong, but I'm going to guess those are speaker protect, the protect circuit. So this must have a conventional protect circuit as opposed to the magnetic field amplifiers, where they actually can quickly shut down the whole power supply instead of breaking the control to the speakers. So yeah, it's a little bit different than the other Carvers. But anyway, let's check the fuse, and then I think we can try to power this up. We now have the signal generator connected in the back. I have the 2 dummy loads connected to the speaker outputs, And these are isolated resistors, and the reason for that is this is a bridgeable amplifier. A lot of these amps that will operate in bridge mode, meaning you can run it as a stereo with 2 separate channels, or you can connect the 2 outputs together to make a single mono amplifier that's very high output, twice the power. So a lot of these bridged amplifiers, you cannot tie the grounds together. So if you use your oscilloscope, and I did videos on this, the actual ground terminal of your scope will actually cause a short in the amplifier if you connect to both channels at the same time. So we're only going to look at one channel at a time and use our isolated resistors, and we should be just fine. Now I have a 150 millivolt signal, which is not turned on yet, fed into both channels, and we're just going to look at the left channel first. So let's get this lined up, and I'm going to turn the amplifier on and just see what happens. And as long as I can get this thing in focus here. All right. So let's turn it on and see what we get. Shut this light off, make it a little clearer. All right, here we go. Power on. Plug in. All right, and the light's dimmed. Okay, the protect circuit kicked in, so that's a good thing. So 150 millivolts. Let's see what kind of output we get, if we get any. And that's good. So we're getting what? 8 volts. Peak to peak, and what was that? About 2.6 volts RMS. Okay, so nice small signal. Let's move the scope over to the other channel, make sure the right channel's working. All right, we're now connected to the right channel. And already I see something a little different. Getting a lot more output on one channel than we are on the other, aren't we? So we're going to have to figure out why that is. Okay, so we've got our 2 AC true RMS meters on there, and I'm going to run, I got 440 hertz, that's just what was on there. Let's go to 1 kilohertz. 1 kilohertz. Okay, and I'm going to turn these on, and theoretically I have exactly the same amplitude going into both channels. So what I should see is equal voltage between both of those. And you can see they are nowhere near the same. Let's do this take 2. So the one probe popped off. Try it again. And you can see we have 3 volts RMS on the left channel and 4.96 on the right channel. And that kind of goes along with this meter, because if you look down here, you can see this meter is indicating just under 1 watt, and this one's indicating just under 3 watts. And if I change the meter range, you could see a little more clearly. Definitely one channel has more output than the other. So there is definitely something not right here. So let's see if we can troubleshoot this a little further. Well, now, getting things ready, and I'm sitting there, and a puff of smoke came right out of this area someplace, and it was a pretty good whiff of smoke. I can still smell it. So the left channel definitely has a problem, and well, it's not smoking anymore. Let's turn it back on and see if it re-smokes. Okay, it turns on. Hold on 1 second. I'm gonna put the scope on that channel again. All right, contact. All right, I'm going to watch the scope right now, because if it goes up in flames, we'll catch it on video here. And strangely enough, my left channel's totally out now. I have plenty of output on the right channel, but nothing on the left channel. So I'll show you that here. All right. And you can see right channel getting 7 volts RMS, and left channel nada. So whatever was causing that reduced output, well, it decided to give up the ghost, and we let out the magic smoke. And the problem with letting the smoke out is you just can't put it back in. So now we have something to troubleshoot. Great. So this is a model TFM-35x, and TFM stands for Transfer Function Modified, I believe. And I think what we just did by letting the smoke out was we modified the transfer function of one or more of these little transistors down in here. So we're going to flip this thing over on the side. We're going to print out some schematics, and we're going to go through and do some basic static tests and see if we can find a faulty component first. And then we'll see where in the schematic that component exists, and that'll help us to understand what other components may have been affected by it. So at least for right now, that's my game plan. So first things first, I cleaned off all that black goo off of there, and actually what that was there was a little, like a rubber bumper that was glued up here. And I think the purpose of that was when the top was sitting on there, if you sat anything heavy on top of the amplifier, it would kind of cushion it on the top of the transformer. So that's, it basically deteriorated and just turned into just gook. Almost like you ever see belts in some of the old tape decks. That's kind of what it reminded me of, that kind of stuff. So cleaned it all off, and that's good now. So back to our problem. We originally had low power output on the left channel, and we had normal function on the right channel. As we were testing the left channel, and of course when the camera wasn't on, a nice little puff of smoke came rising up just out of this area in here, which is your left channel. So you have your speaker protect relay for the left channel right here. You have a couple of transistors. You have your this is Q232, which Q232, this transistor right here, let me kind of get you around where you can see where I'm talking about. There we go. So this transistor and this transistor, these are for monitoring the plus and minus 98 volts, which is the high rail for the outputs. Again, this is a Class G amplifier. If you're not familiar with what a Class G amplifier is, go back and check out the videos that I did on some of the other Carver gear. What was it? The Silver 9T video series, that was a Class G. The M400 video that I did, that's a Class G. And the Carver MXR 2000 that I did was kind of a hybrid Class G, Class H amplifier. So I really get into that, how these stacked rails and everything work on those. So go back and check those out. That way I won't have to repeat all that in this video. So after our puff of smoke, there was no output on the left channel. Even though it was weak before, now it's nothing. We don't see any burned components at all. I looked, nothing, no sign of smoke, no sign of anything cracked or burned up or charred. So this is going to be kind of interesting to troubleshoot it a little bit. Strangely enough, even with the channel being totally out, there's no DC on these speaker terminals. and the protect relay still comes in as if the amplifier is working properly. So we at least know that we don't have the main output transistors, at least on the low rail, the 25 volt rail. We don't have any shorts on those, because if we did, it would put all that voltage down onto the speaker terminals and it would trip this. So whatever went is something earlier in the circuitry. So we're going to have to find out what that is. That's our next goal that we have to find here in troubleshooting this. Okay, I don't know if you can hear this, but it's kicking on and off. And if we look, let's see if I can get the camera loosened up and get it over here where you can see it. See what it's doing? It's just kind of trying to do everything with one hand. So you can see the waveform there. And I don't know if it's going to start smoking again or not. It hasn't smoked since that one time. And strangely enough, this left channel comes back up every now and then. So let's increase the amplitude a little bit. And you can see it's kind of jumping a little bit. And I don't see any smoke. I checked all these components and there is no, looking at the transistors, I don't see anything jumping around on the transistors as far as, voltage. But you can see what's happening there. Let's go up a little more in amplitude. Nothing. All right, so let's turn it off. Let me get this oscilloscope connected permanently, because I was just kind of holding the probe on there. And let's see if we can get it to start doing it again. So we can just barely see the very top of the circuit right now. And the amp is still turned on. And we can kind of see the scope here. And hopefully, if this thing decides to act up, we'll be able to catch everything all at once. So let's take a look and see what we get. Audio on. And you can see it's kind of jumping over there a little bit. And sorry about the glare from the lights. I just can't get the lighting at this angle. And we can go up in amplitude, and now it's working. And that's pretty substantial there. Let's go. Now it's going to work all day long. And this is the problem that you run into when you have intermittent component failure like this. And being that this is a direct coupled amplifier, any one transistor in the chain can cause all of them to shut down. And of course you have the protect circuit that's coming in very quickly when it sees any DC on the outputs, and that just makes it a little more difficult. So really what we have to do is get it into a failed state. And the only clue that I had was that the left channel is weaker than the right channel, or at least it was. And intermittently you'll see some noise on the left channel, and then eventually the protect circuit will kick in, and then it'll drop back out and the amp will come on and work. I'm starting to wonder if maybe we just don't have a cold solder joint on the back of the board. And the reason I say that is it doesn't seem to be a failing transistor the way that they normally fail. Usually you can get your meter and you can go on to the leads of the transistors, and you'll see the voltage jumping around towards the outputs. Even if a transistor earlier in the stage is the one that's failing, you'll see an area where like all of them from that point on will start fluctuating like that. And we're not getting that. So we just have to keep beating on it here until we get it to fail. All right, let's keep going. There's clipping. I don't want to run it too hard at clipping, because that's 250 watts per channel. All right, I'm going to turn it off. Let's move the probes over to the other channel, and let's see what the signal looks like on that side. There we go. And you can see, same thing, clipping. And how about that? Both channels are totally symmetrical now. Go figure. Unbelievable. And I mean, I'm pushing some pretty good power into it. Okay, well, I guess we're just going to have to keep waiting. And I think what we're going to do is, if it is a solder joint on the board, we should be able to flex the board and get it to fail. So let's get our little chopstick out and let's just push around on the board with the signal going through it. So I'm going to put just a little bit of power there, and that's roughly, let's see, about 10 or 12 watts right there. So it's not pushing it very hard. So let's go flex the board. This board is very thin and flexible. Nope, I'm not getting anything. And strangely enough, these heat sinks, I mean, they're coming up to room temperature, but really they're not even getting warm. Nope. So I don't think it's a loose bad track on the back of the board or anything now. So, well, I'm at a little bit of a loss. I guess we're just going to have to keep, I'm just going to keep running it for a while, and if it fails again, I'll turn the camera back on. Well, as you can see, I put the cover back on this one. So I can't ever say that I let the smoke out of something and then it fixed it. But in this case, that's just what happened. This thing's been running for over an hour, and I've been turning it on and off prior to this. It will not fail. You can see I'm running a nice solid about 40 watts per channel. They're very symmetrical. I have the oscilloscope connected to the bad channel and an absolute clean sine wave coming out. It just won't do it anymore. And you know, the strange thing is, for a long time, we saw the protect circuit clicking on and off. It was very intermittent. A lot of times I couldn't even get the camera turned on fast enough that it would start working again. And now, whatever it is, it has repaired itself. Now, there are a couple of options that we can do with this. Because first of all, this is not much of a learning video, is it? Because we never really found the problem, the cause of the problem, and we never really effected a repair on it. So where does this lead us? Well, you can't turn it over to the customer knowing that that problem is still hiding in there someplace. So what do? Well, number one, we can continue to use it for the next, because the customer's not going to pick this up anytime soon. He said I can have it as long as I want. He doesn't need it right now. So we can just continue to put it off to the side and just turn it on and use it and wait till the problem comes back, if it comes back. The other option would be to kind of take the shotgun approach and replace a whole bunch of components. Now, in this particular amplifier, it's a pain to get the board out of this because there is no bottom cover. The chassis is the bottom of the amplifier, so we would have to remove all the connectors and things, and we would have to remove the board from the whole chassis in order to get underneath it to replace the components. But beyond that, there are only a handful of small transistors other than the outputs, and I know it's not an output. It really seems to be, first of all, the smoke came out in the driver section, those little driver transistors. So most likely something in that area. Maybe it was a resistor that was smoking a little bit. I measured all the resistors. They are all perfectly on resistance, and I don't see any burn marks or cracks on any of them, but I have a feeling that the smoke was actually coming from a resistor because we had an intermittent transistor short. So back to what I was saying, you could replace just the small signal transistors on both channels just to be safe, and you're talking maybe about 10 or 12 transistors altogether, maybe a few more than that. I mean, if we look at the schematic, I pulled this plug out and the thing still tripped the protect circuit, so we know it's not the preamp. So it's got to be something in here, and you can see there's only a handful. These are all the big outputs down here, but just a handful of the small transistors. They're all very inexpensive. They're all ones that I have in stock, or at least I have replacement ones in stock. So it would be easy to replace them once I pulled the board out. So that's one option. And then, again, there's not much else it could be. There are only a couple of electrolytic capacitors. There's no tantalum capacitors. Diodes really don't intermittently short like that. I typically don't see that. So I'm still leaning towards transistors. Or we can just, like I said, wait for it to fail and then trace it to the individual component. At the end of the day, if one of the components is bad, you're probably, while you're in there, going to replace them all anyway. But that's still not much of a video, is it? If you don't see the failed component and then I replace a bunch of transistors and it works the same as it did before, we really didn't show you much on the video. So I'm going to think on this one a little bit. I'm probably going to continue to run it for a while longer, and you could see the whole time we're having this conversation, this thing's running perfectly at about 40 watts per channel, and it's not getting super hot. I'm just feeling, lukewarm coming out of it. Again, I think there was a transistor that is intermittent, and it decided to quit being intermittent for a while. So there you have it. I would spend more time on this project, but I know it's been a long time since I've posted a video. I've been really busy. I have a project I'm working on the house. I've had a whole ton of things come up at work that have been consuming a lot of my time. And of course, this amplifier just hasn't been cooperating. So we're going to get this off the bench, and I'm going to bring on another project. And I'm going to post this video even though there isn't a whole lot to watch in it, and I'll probably post a little warning at the beginning of the video to let you all know that I don't fix this really. So if you don't want to watch it, you've been forewarned. And we'll go from there. Other than that, I just wanted to update you all and let you know I'm still here. Everything's going well, and videos will be coming pretty soon here, as soon as I can get back into the swing of things, and we'll be back before you know it. But thank you all, and thank you if you did watch this. I thank you for watching it. Sorry that we couldn't make it a little more interesting, but sometimes you run into these things. All right, peace, joy, happiness, and good health in your lives, and we'll see you soon. Bye-bye.